In this lesson, we're going to learn how to isolate variables. In a lot of the formulas that you're going to have in your other courses and stuff, you're going to have equations that are going to have a lot of different variables. And if it says isolate a variable, that means get that variable alone, all on one side of the equal to sign. So, for example, if we wanted to isolate, say, z in some sort of an equation, that means that when I'm done, it's going to be a z equals something, and there could be all sorts of other variables on the other side. And what we're going to do here is our variables are going to be just like numbers. We can add them, subtract them, multiply them, divide them just like we do with numbers. And of course, since these are equations, they're going to have equal to signs, and we're going to be moving the variables back and forth across the equal to sign. We usually work in reverse order of operations, is that's usually the simplest way to move things around and isolate variables and stuff. So let's go ahead and work a few examples. In the first example, we want to get the y alone. It says solve for y or isolate y. So the first thing I would do is if I had 7x minus 3y is equal to 8, I'm going to move the 7x over to the other side. So what I would do is I would subtract 7x from this side, the left side, and I would add it. I would also subtract it from the other side. So let's go ahead and do that. So I would have 7x minus 7x. Of course, there's my minus 3y is equal to 8 minus 7x. And what I'm going to get now is I'll have a minus 3y is equal to a negative 7x plus 8. So what I did is I went ahead and just moved the 7x term, the minus 7x, to in front of the 8, just because I like it there better. That's more of a standard form of how we write things. Now I need to get the y alone, so I'm just going to divide both sides by a negative 3. And remember, both sides have to divide by the negative 3. So what that's going to mean is that this is going to be equal to a negative 7 over a negative 3. This portion right here is going to be over the negative 3. So I will have a negative 7x all over a minus 3. And then I have plus 8 all over negative 3. So simplifying that, I'm going to have the y. That's alone now. And this side I'll have 7/3 x, because it's negative divided by a negative is a positive, minus 8/3. That's my answer. Okay, let's do the next one. It says solve for y. And let's write the equation again. X plus x y equal to 1. Reverse order of operations. Let's get rid of that x. So if I subtract x from both sides, I'm going to get xy is equal to 1 minus x, which I'm going to rewrite as xy is equal to a negative x plus 1. Now then, what I need to do is get this y all alone, and it's got the x multiplied by it, so let's divide both sides by x. And what I'm going to end up with is y equal to, let's take and split this up into negative x over x plus 1 over x. This term of a negative x over x is really just the same thing as a negative 1. So I have y is equal, because the x's will cancel, giving me a negative 1 plus 1 all over x. There's my answer. Okay, let's look at the last example. Oh, it's not the last example. So let's solve for P2. So what we have is we have R is equal to P1 times A plus P2 times C. And I want to get the P2 all alone, right? It says solve for P2. So the first thing I need to do is work reverse order of operations. We're going to subtract this P1A from both sides. That would give me r minus p1a is equal to p2 times c. So to get rid of the c that's with the p2, let's divide both sides by the c. And what I'm going to have is r minus p1a all over c is equal to p2. Now in this case, I'm just going to leave it like that. I could split this up. One possible answer would be r all over c minus p1a all over c is equal to p2 by splitting up each portions of my numerator and putting that over the denominator. But so actually both of those are correct. That's probably how we would see most formulas written, so I'm going to leave it like that. Okay, the last example, it says solve for h, so we need to get this h alone. So let's rewrite the problem. V is equal to 1/3 pi r squared. Now, to get rid of the 3, the 1/3, and put it on the other side, I would have to multiply both sides by 3. That gives me 3v is equal to pi r squared. Now let's get rid of the pi part, so let's divide both sides by pi. Now I would have 3v all over pi is equal to r squared, and my last step then is to get rid of the square on the r. If I take and square root both sides, the r squared would just become an r, so my final answer is going to be the square root of 3v all over pi is equal to r. And that's it.